Hello to everyone. First of all, thank you for attending the 4th Workspace Live Code Along. A huge thank you as well to the speaker, Filip Schouwenaars, who together with DataCamp and especially all of you made this event possible. Once again, I'll remind you the session is recorded and the link to the video will be posted through Slack, email, and social media platforms. Moving to the next slide. A little bit about DataCamp itself. So our mission statement is to democratize data science education and make data literacy accessible to millions of people and businesses around the world through our learning platforms and now also through our DataCamp Workspace, certification, and events such as this live code along. Moving to the next slide, talking about our speaker today. You may have seen Filip before in some interactive courses here at DataCamp, but now he is the product manager of DataCamp Workspace. Today, he will be more than happy to explain how you can start your own data analysis with just a few clicks using Workspace. Today's live code along is divided into several parts. First, Filip will show you how you can start your workspace from a template and add it to your portfolio. Next, Filip will start a workspace from a GitHub repository and explain how you can add this to your portfolio as well. And finally, he will connect the workspace to a relational database and build a data report. Every part will take about 30 minutes and will have its own Q&A section. If you have any questions, feel free to ask them via the questions button on the control panel of GoToWebinar. Filip will then try his best to answer them during the corresponding Q&A session. Finally, we want to remind everyone that this session is being recorded and the link will be shared with you later on Slack, email, and social media platforms. Thank you for your attention, and now the live code along itself will begin. Filip, over to you.
Hello, can you hear me? Ryan, just checking.
Yes, loud and clear.
Okay, perfect. All right, hi all. It's really cool to see that you've attended such numerous so numerously to this live code along, the 4th one on DataCamp Workspace. It's going to be a little bit different from the code alongs we did before. So as I'm doing different data analyses that you'll be able to follow along and code along yourself, I will also be showing some of the latest features we've been adding to DataCamp Workspace. So in the first case, so in case you've never tried your hand at DataCamp Workspace yet, basically what DataCamp Workspace is, it's as easy as taking a couple of courses on DataCamp. Like we made learning very easy, make it possible in a couple of seconds, couple of clicks, you can get started learning data science. With Workspace, it's the same, but for your own data analysis projects. So you can get started with your own data science project, very easy, with a couple of clicks, no installation, no configuration required. So if you haven't explored, like you haven't worked with your Workspace yet, this is what you'll see if you click on the Workspace tab when you're logged in. It's important to note that for people who are in a B2B group or a B2B account, they don't necessarily have access to DataCamp Workspace. For these people, I suggest that they quickly create a personal account on their personal email so that they can still get access to DataCamp Workspace. So once you click on Get Started for Free, you basically land in your Workspace dashboard. So this is my Workspace dashboard. Of course, there's tons and tons of workspaces on here because I'm working day in, day out on making DataCamp Workspace the place where you can come to do your data science projects. But in your case, probably there'll be less workspaces here. So basically every tile here is a DataCamp Workspace. So in the first part of this code along, what I want to do is basically walk you through the steps necessary to basically do your own data science project with an interesting data set that we have prepared for you. So suppose you already took a couple of courses on DataCamp, you took a couple of DataCamp projects, and you're basically ready to take the next step and basically say, like, I want to do a free-form project where nobody is telling me what to do. I just want an interesting data set to analyze. I want to analyze it, and I basically want to share my work with the world. For that, we have built DataCamp Workspace templates that you can see here on the left-hand side. So you see datasets, recipes, and playbooks. So let me basically look at all templates first, and we see a bunch of templates. So all kinds of different templates. There's dataset templates to really get you started with a data science project and starting with a dataset. There's recipes that give you tips on how you can solve typical common problems that you basically have to, like common things you'd have to do in a data science project. And then there's also playbooks, which are longer form templates that really solve a specific business problem. For our specific use case, we will, let me quickly check if there are already any questions. Okay, for our use case, we will basically start a workspace from a dataset template. So there's a bunch of stuff I can choose from here, like I can analyze measles data, I can analyze loan data, but in my case, let's analyze some NBA shooting data. So I click on this, and I can basically preview this template to see if this is a template I'm interested in exploring. So it's apparently a dataset based on statistics to be found on the NBA websites about basketball. I see that the data frame contains a couple of columns like shooter, XY, range, defender, score. Let's say I find this interesting, and let's use this template. Also, I'll be using the Python programming language throughout this template. You're free to use R, but then I can't guarantee that you'll be able to follow along as easily because you'll constantly have to translate it from Python to R. So I strongly recommend that you also use Python. So I just clicked on use template, and what this will do, this will launch a DataCamp workspace for me without me having to configure anything. So this launched JupyterLab IDE, which is a very commonly used integrated development environment for data science, and all the files necessary for me to get started with my analyses are basically available here. So I see the same things that I saw in the template preview before. I indeed see it's a dataset based on statistics, can be found on the NBA website. There's already some interesting, like some useful code for me that imports the data from the CSV that's also contained inside this DataCamp workspace. There's even a printout, so let me already run this. So this is the first, so I use Shift-Enter to execute the code in these cells. You can also always use the play button here at the top. All right, so that's that. Then I'm going to import the CSV, and I see that the first 5 rows are indeed, there's like the shooter. So that's the name of the basketball player that did some shots. X and Y, that's then the position from where this the shooter was like basically was taking the shot at the hoop. So it's the horizontal distance of the shot taken from the basket in feet, and the Y is the vertical distance. Okay, interesting. All right, what do I see else? Like who was the defender? So who was trying to basically field off the player's shot? And then there's a score, whether or not the shot has been made or the shot has been missed. So that I also see in the some sample code that was already included. I see indeed that the score is either made or missed. All right, cool. I think I have a pretty good sense of this data set. So like I'm gonna cut a couple of cells to clean this up here, like this. I can also use DD for that. And then I get also a suggestion for some interesting questions for me to answer. So indeed, I get to explore this exciting data set. I can't wait, I'm super excited. Can't think of where to start, try a couple of questions. So I see a pretty cool plot here, like plot shots taken and missed via scatter plots. And you can look at this example for shots taken by Russell Westbrook to give some inspiration. So I basically get a suggestions, like maybe you should try to recreate this plot over here. So let me do that, right? I'll just get rid of this. And let's say, let's plot shots taken and missed via scatter plots like this. All right. So now I can start coding. So the first thing I should do, I guess, is basically get the image of the basketball court in Python. And if I look here on the side, I already see that there's an NBA court.jpg in there. So what can I do? I see that already Mapleflip byplot.splt is loaded in. So I can basically say, I can use the imRead function of Matplotlib. And just to remind you, this is actually a code along, so I highly recommend you to like code along as I'm coding through this, right? In a like somewhat later, we will also share a publication, a workspace publication with all of the code that we've written so far, so that like if you missed a step here or there, you can still like fill it in and basically still create a publication and feature it on your DataCamp profile page. So I'll do like this, like I'm reading out this image over here. I'll also check real quick what the width is of this, this image. And I'll also do that for the height. And let me quickly print out width and height. Okay, so I see that this is an image of 1,365 pixels by 1,455 pixels. This is something that will be interesting later on. I can also see what the image would look like if I print it out. So I'll do plt.show. And I see indeed that so it's basically the pixels have been converted to the axis units here. Okay, cool. So next thing I would like to do is basically I'll draw all of these points, basically all of these different observations for a certain shooter on this image. So let me start by creating a figure, a Mapleflip figure. And let's say we make it like size 8, like we want to make it 8 in width, and then we also want to make it 8 in height. So you do like this, width times height. That way we're sure we're respecting the aspect ratio that was defined by the image in the first place. If I do plt.show like this, I'll first add some axes. That's basically drawing axes on the image. This. All right, so this is just our blank canvas. The next thing we can do is basically on these axes now, that we will later on drop the scatter plots on, we can now show the image, so like this. All right, great. So that's that. We can get rid of this now. We don't no longer need this. All right, this is perfect. And what you also see here is whenever you create a plot, just use x.imshow, it will always print out like the plotting object behind the scenes. If you want to avoid that, you can either use a semicolon here, then the text disappears, or you can also use plt.show, and then it's also not happening. All right. What we'll do in addition, so basically what we have to do now is we want to get the x coordinates and the y coordinates and basically draw them on here. But we immediately see that the x coordinates are -3.8, 5.5, while here we're dealing with a 0 to 1,400 range, and here we're dealing with a 0 to 1,300 range. I'm getting a request to speak slightly a bit slower, so I'll do that. And also get a request to zoom in a bit, so I'll also do that. I hope this is better for people to follow along. But so what I was talking about, I said, so basically the x-axis and the y-axis is like they're a completely different scale than the ones in here. So we'll probably have to do some sort of transformations to make sure that the dots of where the player was when he threw the ball, that still works out. So let's see. Let's just very stupidly maybe just try to plot the x and y coordinates without making any changes. So we'll do scatter, and then we select from the data frame that was loaded in the x coordinates, and we select from the data frame that was loaded in the y coordinates. And then like let's give the images, like let's give the points size of 3, and then we use the color. No, but I'll wait with that. Wait, I'll do like this. And what do we see? Yeah, so as expected, what do we see? Like it's all in here at the top, like the dots are all here. So there's clearly some scaling that needs to be done. So what we can do to scale is basically, if you know that an NBA court, like the width of an NBA court is 50 feet, and our image is like 1,450 pixels wide, roughly, what we can do is basically do create an X rescale. I'll create a X rescaled like this, and say that we will do divided by width times, we will divide it by width. No, we will divide it by 50 because that's the width of the field. And then we will multiply it with width over here. And we'll do the same thing with y rescaled. df y, and we divide it. In this case, what we're seeing is basically half the length of a basketball court. So that's 47 feet. So we can divide it by 47. That's just information I know, right? Like that the width of a basketball field is 50 and the height, like the length of a basketball court is like half of the length is 47. So let's now print rescaled like this and rescaled like that. And this is already somewhat better, but there's still some work to do, right? We clearly can distinguish the circles of our plot over here, but it seems like we have to flip it around, like the y-axis, we have to flip it around, and the x-axis that's still skewed. And that makes sense because the x-axis here, you see it's -3, -0.1, -0.5. So it's counted from like considering this to be the center rather than the bottom left, like the top left screen being the center. So what we can do here is we basically add 0.5 to this, like that way we normalize it to, this is already much better, like the x-axis seems to be correct now, but then the y-axis, what do we need to do? We have to flip it around. So what we then do here is 1 minus divided by 74. This is already somewhat better, but not yet perfect. That's because I made a mistake here. I should do like this, right? It's 1 minus and then dfy divided by 47 times the height. All right, so this is already much better, but we do see that there's slightly, like it's slightly skewed to the left-hand side. So that's probably something that has to do with our image. So it seems like we can add a couple of maybe like 0.55 or something. And then we see that the shots are cleanly, maybe 3.5, something like this. Yeah, this is much better. So we see here clearly that now there's a lot of shots taken outside of like the 3-pointer range. So this is actually a pretty good depiction. But of course, like if we compare this to the image over here, we still didn't do filtering based on who is the player. And we still haven't given the points different color depending on whether the shot was made or the shot was missed, right? So maybe before I do that, I also want to clean up a bit. So somebody already asked, like, can you talk a bit about the Adaxis? So what you do in Mapleflip, you basically start from a canvas. I create a figure, then you add the axes. And what you're saying here is that the origin should be 0, and here the origin should be 0 as well, and the axis should have ticks of step 1. But that's something we can talk about a little more later on. Something you can also check on the documentation. So what I'll do first is I'll set the ticks to be like this so that we no longer see these annoying numbers on the side because they don't add a lot of value. And I'll do the same for the light ticks as well. So now like the numbers are gone here. And by the way, every time that you see me executing a cell, I'm basically using Shift and Enter as a short key. It's just the same as clicking on the play button here. Then something else I can do, because we see like a double rectangle here. So what I'll do is I'll just set off, like I use PLT axis and I'll just use off like this. All right, so this is now clean, no double lines or something. This is something I can get started. Like this is something I can continue on. The first thing we'll do is make sure that there's some nice colors in there, right? So we can use, basically what we want to do, I'll open up in a new code cell. I basically want to give every point a color depending on whether the shot was hit or the shot was missed. So that means that we have to go from the score column to a new column, and let's call the column color, so that I can immediately use this inside my Mapleflip function. So what I'll do here is I'll use df player score, and then I'll use the map function, and then I'll say made should be converted to green, so that made shots will appear in green later on, and then missed, I should convert it into red. All right. So df player is not defined, it's df, of course. So what we see indeed that made shots have been converted to green, missed shots have been converted to red. So this I can now basically add here, and I can create a new column called color like this that I add to my data frame. And what I can do now here is say color equals df color, and then I can say toList. And if I do like this, now I see indeed very nicely all the missed shots in red, all the made shots in green. Maybe the size can be somewhat larger here. The S stands for size, so let me make that 10 maybe. Like this, it's already better again. But again, this is the entire data set, right? If we look at the dimensions of this data set, shape, we see it's 776 shots from 4 different players, right? So what I'll do now as a last step is basically do a filtering to make sure that I only select the shots by For example, what was the suggestion? Russell Westbrook. So I'll already copy that name, so I don't have to do that in a second. So I first have to do the filtering now. So if you remember from pandas, the filtering happens as you can basically generate like a series of booleans by using the shooter in this case and saying it has to be equal to Russell Westbrook. I'll also copy that to another cell so we can experiment with that. So indeed we get a series that is false or true depending on whether the shooter is Russell Westbrook. Now we can basically subset that same data frame like this by surrounding it by brackets and putting the df in front. We can basically subset that, and now we only get shots by Russell Westbrook, and indeed we see Russell Westbrook is the only shooter in here. So that's we got, and we can copy over here, and I'll call this, and I'll give this the name of a new data set, new data frame, df player, and then I'll do like this, and like this, and like this. So maybe also to make sure that my code is still fully reproducible, let me start at the top. I import NumPy. I just use Shift-Enter to click through this entire thing. And what do we see now? Now we see indeed only the shots by Russell Westbrook. And if we compare it to the picture that was created here, indeed, it's exactly the same. So we see the red dots and the green dots. Maybe we can make it slightly less big by changing it to 8 here. And then we see indeed a good looking plot over here. So let's say now that I'm happy with this plot that I put together. I'm also going to clean this up a bit. I'm just going to say, let's plot shots taken by Russell Westbrook and color them depending on whether or not the shot was made. Like this. All right, cool. This is code I'll like. This I'll get rid of. So suppose I'm now super happy with the way this code looks. The next step in DataCamp Workspace is actually, it's super easy now to say, I'm happy with the way this notebook looks. I want to share this with the world, right? So let's do that. You can basically click on share, and then here you can click on publish workspace. You can just publish the notebook, so you have to select which IPython notebook you want to create a publication from. In this case, there's only one IPython notebook inside the workspace, so there's just no notebook.ipynb to choose from. I can just click on publish here. It's going to load for a second. It's basically rerunning the workspace from top to bottom again to make sure that every code cell that is dependent on the other one, like it still all works and you didn't make any mistakes in the meantime. And now I have a publication I can super easily share with friends, with colleagues, right? So this is a publication. It's clearly that it's mine, so it has my name on it. You can even give it an upvote. You can also share this with friends and colleagues to give you an upvote on it. What you also see here in the workspace publication, in the sharing status, is that it has public access. So that means that everybody who has the link to this publication will be able to access this. And that also, it's automatically featured. The publication is automatically featured on my profile page. What does that mean? That's basically, if I go here to my DataCamp profile, I open up my profile in a new tab. What do I see? I see my NBA shooting data appear here. So as such, like super easily, you're able to start from data science project, like from like the NBA data set, do some work on it, then generate a publication from it, and then feature that publication on your profile page where it's shown next to all the courses you completed, all the projects you completed, all the tracks you potentially completed. In my case, I didn't complete any tracks, but I'm sure like some of you have already completed a couple of DataCamp tracks. So rather than having to wrangle GitHub to make sure that your notebooks are shown on there and rendered nicely, basically we have tried to make that step very easy with DataCamp Workspace, being able to create a publication very easily, basically. All right, so I'm going to pause here for a second and have a look at the questions. So there's a question by He. She asked me to pause for a minute. I think Senna, who's conducting the live code along, he will share a publication that I made in the past that basically shows all of the code that I've written so far, or like roughly, because I kind of winged it a bit. But he will share the solution code with you so that you can still review this if you couldn't follow along entirely. Then Asha also asked the question to go through the second cell again. If she means that the second cell is this pandas read_csv call, what this is basically doing is from the pandas package, it's using pandas as being imported as PD. So the read_csv function is called, and then we point to the CSV that we want to load in, and the CSV is here in this case. So that's basically taking the data from the CSV file into, like, loading it into Python into a data frame. And then with the head function, we look at the first 5 records. I hope that that answers the question. Then there's also a question by Asha who asks whether this workspace can now be posted on GitHub. Yes, this is possible. So what you have here inside Jupyter Notebook is a terminal. So inside the Jupyter Lab interface, you can just go through the launcher and open up the terminal. And in here, you can basically, like I can create, like on GitHub, I'm quickly going to kill this. It shouldn't show. DataCamp. So on my personal repository, like on my personal profile, it's perfectly possible to create a new repository here and then just add the remote here, authenticate yourself and push these changes to GitHub. So this is all possible from inside DataCamp Workspace. And it's also something I can show you later on. Right. So maybe we have a couple of minutes left. Let me walk through exactly when I think that's what Asha is asking for like what is exactly happening here. So the first thing we do is we create a figure with a certain size. So it's width, like the width in this case is 4, and the height in this case is 4. And basically we use the width times height aspect ratio, like the width by height aspect ratio, to make sure that it fits basically the image that we read in. Then we add a couple of axes with origin 0 and step size 1 and 1 in both directions. Then the first thing we basically plot on that canvas is the image itself, so the image that we read in from this JPEG. Then we use set x ticks, set y ticks to empty arrays so that we get rid of the tick labels on the left-hand side and the bottom side. Then we also just disable all of the axes so that you don't show the axes. And then we use, basically we rescale x, we divide it by 50 because the width of a field is 50 feet. And we add roughly 0.5 to it so that the coordinates are shifted properly. And then we multiply by the width of the image again. The width of the image in this case was around 1,200 pixels. And we do the same thing for y, only there the transformation is slightly different. In that case, we basically have to flip it around, like we do 1 minus and then divide it by 47. And then we do that times the height, so the number of pixels in the height. Then we create a new column color that we mapped from the column score, and we basically map made to green and we map missed to red, and we store that into a new column in the data frame color. And then finally, we do a filtering on the data frame where we just filter on the Russell Westbrook shooter, and then we store that like that. We create a new data frame from that, and then we can use these axes that we created here to basically add a scatter plot. And then we use X rescaled, Y rescaled, because otherwise it will look very weird. Like we have to use the rescaled values here. We choose to have a scatter plot with dots that have size 10. And then we also color it in using DF player color and then convert it to a list. And then if we plot it, we see this nice image. All right, so last question, and I think then we should continue because there's still lots of things to cover. Was Daniel with a question, could you elaborate on the subset function? I didn't understand how you made a filter for the specific player. So yeah, sure. So this is DF. So this is the data frame for all players, right? The first thing I do is basically understand which records or which observations in this data frame are for the shooter Russell Westbrook. So what I do is I basically check, I do like this. So I look at the shooter. That's basically a series with only the shooter column in there. And then I see which ones of these are equal to Russell Westbrook. I do like this. And then I see false, false, false. I can also do this with another one, right? I can also do this with Chris Paul, for example, with Seth Curry, for example. And in that case, you'll see a different result. And you'll see that the first couple of observations, for those it will be true, because if you compare that to DF, we see indeed the first one is Seth Curry. So for that one, it's true. So if we now use this, if we now use this to subset DF, that's basically saying keep the observations in DF for which this filtering evaluates to true. So if the corresponding the corresponding element in the series is true, then keep it. If the corresponding element in the series is false, then drop it. So in the case of Seth Curry, what will happen? Oh, there's an unmatched. That should be like this. What do we see? We only have shooter Seth Curry anymore. If we change this by Russell Westbrook, Russell with 2 L's, what we see, we only keep the shots by Russell Westbrook. So that's how that comes together. And then the last thing you have to do is basically store that result into a new data frame, DF player, which is then basically some sort of a trimmed down version. It's like a selection of the data frame. And that's something you can then use in your plot. But it would be perfectly possible to also change this to like Seth Curry, for example. And then, of course, we get a different picture, right? That's the nice thing about programming. You only have to change one thing. You don't have to recalculate it all. We just get another shooter profile, so to say, shooter passport, if you will. And again, you can share this, publish this, and feature this on your profile page. All right, so that was the first bit of like DataCamp Workspace magic I wanted to show you. Now for the next part. I'm just going to drink a glass of water first. All right, so this was your, like here we created a workspace from the NBA shooting data from a dataset template. But of course, you're not limited to this vast library of templates out there, like out there in the DataCamp product. There's also tons of interesting stuff on GitHub for you to explore, right? So rather than having to go through GitHub, download all the files there, import them into DataCamp Workspace, we actually try to make it super easy for you to start a new workspace from a GitHub repository. To that end, I created a GitHub repository called Stocks and COVID that contains already like the first steps of an analysis on how some stocks have been impacted by the COVID pandemic. So rather than me now having to, for example, download this as a zip file, what I can do is basically just copy the profile name and the name of the repository from GitHub. I'm going to close this off so I keep things clean. And I can just, from my workspace dashboard, click on GitHub repository. What I can do here, I can paste it in. I'll leave this open for a while so that you can follow along. So it's basically FILIPSEH/stocks and COVID. Maybe Sene, you can drop that in the chat so that people can copy this over easily. You don't have to type this all. And then I can choose on which technology I want to open it. It's a bit similar to the technology you could choose when you were opening it from a template. In this case, I will again work in Python. That means that this GitHub repository will be opened up as a workspace inside the JupyterLab IDE for me to start exploring. So it's FILIPSEH/stocks and COVID, so using these dashes here. All right, so click on create now. And again, as usual, as before, a new workspace is created. This time the workspace is populated using files from GitHub. Again, the JupyterLab loading icon. And what do we see? We see notebook.ipynb. And indeed, so this is something I've already prepared. So in this notebook, we'll see how the stock of some large corporations performed when the pandemic swept the world. To accomplish this, we'll use the Yahoo Finance data and some COVID cases data made available by the New York Times. So this is the start. So this is already a typo I should fix. So I already prepared some code that pip installs Y Finance package. So that's the Yahoo Finance package that allows us to easily get finance data from the Yahoo API. As you notice, I also added percentage signs and capture here. That's basically make sure that any output that the cell generates is not shown in the notebook. Otherwise, I get like a long list of installation logs. This is something that's not interesting for my analysis, so that's why I use the percentage capture sign here. Then there's also already some imports that are happening. Y Finance is YF, pandas as PD, NumPy as NP. There's also some like configuring of my images so that I have like good-looking images. And then it's already downloading stock market data for 4 big companies, namely Microsoft, Netflix, Booking, and American Airlines. And I choose Microsoft and Netflix because these are like pandemic-proof companies in a way, or you would expect these companies to be pandemic-proof, like with the entire movement to working from home. This must have been good for Microsoft. Netflix, with everybody being at home, binging series, binging movies, must have been good for Netflix's revenue. On the other hand, we have Booking, which is like a hospitality platform for arranging hotel bookings. Probably with all the travel restrictions, we would expect these to perform worse. And American Airlines, I think that goes without saying, it's basically one of the biggest airlines in the world, with a lot of planes being grounded, empty flights. Also, they must have experienced quite a rough time in the past years or so, couple of years. So what we do, this is already in there, Yahoo Finance, download it. We basically combine here the ticker symbols. This is all code that is already there if you created a workspace from the GitHub repository. I first have to run all of this, of course. And while this is running, I quickly want to highlight that there's already a solution with the IPython notebook inside this workspace. So this should allow you to, like if you are no longer following along with me, you can basically have a quick peek at the solution so that you can catch up again. So if you're wondering like, hey, what was this step about, or I missed a part, you can just have a look at solution IPython and catch up again. All right, so I already executed these 3 steps here. And what I'll do as well, I'll create a chart here. Okay, so what do we see? And this is obvious, of course, like Booking, it's like the stocks of Booking, they just trade at a very high price. And the stock of Netflix is at like a fourth of that price, and then Microsoft even less, and Netflix way, way less. But actually, like the absolute stock price is not something that's super interesting to us, right? We are interested in how basically the trends were. So in that sense, what we should do is basically normalize all of these stocks so that we can transfer, like we normalize them all so that the stock value is like the minimum of every stock is 0 and the maximum of every stock is 1. So that's something we can do, right? So we have closes here. Maybe the first thing we can do is have a look at this closes chart. I'll do like this, I'll disable this, and I'll have a look at closes. So what do we see? We see a pandas data frame with the index, the date, and then we have the 3 tickers, like the 4 ticker symbols, AL, BKNG, MSFT, and FLX. So what we do is, suppose we want to normalize the stock for AAL. We can do like this. And then we select that. But what we should do now is basically do closes AAL minus the minimum. This is like a standard normalization, like this. And then we divide that by the maximum minus the minimum. So the maximum minus closes AAL, not ALL, minus the minimum. All right. So if we now plot closes, closes AAL at least, what do we see now? All of the stocks are normalized, right? I can also plot this, I hope. So we see here now the stocks have been normalized between 0 and 1. And we already see, like when the pandemic started, like crazy drop for American Airlines, right? From 1 all the way to 0.2. That must be devastating, right? So that's like the 80% of the stock value lost. So I can do the same thing for all of these, like Microsoft, Netflix, Booking, but that would be not dry, as in do not repeat yourself. So we'll just write a quick loop for that. So I'll do for I in tickers. So that's basically the ticker symbols that I defined here. And I'll just replace AAL. I'll just call it tick for every tick in tickers. I'm going to use AL. I'm going to like swap out AL by tick. This, like this, and like this. So now if I plot all of these closes, what do I see? Now it's way easier to compare the different plots, right? And now we also see trends because other stocks were very low in value, like you didn't see the trends in between them. But now booking has been normalized and you see basically all stocks, regardless of like what sector they're in and how pandemic proof they are, they all crashed in March, right? So what would be interesting now is to basically overlay this data with COVID cases count data and see whether there is some sort of a correlation between the cases count, and we'll take the cases count in the US as it's still like the biggest economy in the world, and see whether there's some sort of a correlation there, right? So I'll do plt.show to get rid of this excess subplot. So I'm already thinking about the quality of my publication later on. All right, so the first thing we want to do, so there's already a CSV in here called the COVID cases. So I can start from that. So I'll do import. So I have to change this to a code cell. I can do like this, change to a code cell. Great. I'll do import pandascsv. I can also do import numpy as numpy. And then I will use COVID pd read CSV, and then I'll get the COVID cases.csv. I'll say that the index column, I can look at this by the way, and I want to set the index to the date so that later on we can easily merge this with the other data frame that already contained the date as the index as well. So we say index equals date, and then I'm only interested in the cases columns. I'm not interested in the deaths columns. So we use the columns. We only import the date column, and we only import the cases column. All right, like this. Oh, something wrong. It should not be index. It should be index col. All right, like this. So what we did here, we read the CSV from pandas, COVID cases.csv. We set that to use the date and the cases columns, so to ignore the deaths column, and then to use the date column as the index of the pandas data frame. If we now also set the, so this is still, let me check, if I do COVID dtype, then I see that, or COVID, let me see what the index is like. So what we see is that the type of the index is still an object, but the thing is, it's actually a date. So we have to fix this to make sure that the index is actually a date time. So we do to date time COVID.index, right, like this. And if we now check COVID.index and we check the type, then we see that it's this time it's a date time, right? Great. So if we look at COVID heads, what do we see? Indeed, basically for every date, there is now a case count. Great. So if we try to plot this data, what do we see? That actually these COVID case counts, they're cumulative counts. It's basically what New York Times did in their data set. It's just like a counter that went up and up and up. So the number here is basically all the deaths before that date in October. The thing is, we are interested in daily case counts. So in a way, we have to uncumulate the cumulative sum that happened here, right? And this is a bit tricky. I'm going to copy over some code that I already created, and I'm just going to walk you through it. Okay. So I just copied it over here. So what the first thing I do, I take the cases column and I convert it into a NumPy array, so I can do easy mathematical operations with it. Then to go from the cumulative sum, I basically create a cumulative sum shifted. So I actually shift the entire array one element to the left, and then I do the cum sum minus the cum sum shifted. That way, we only keep the deltas, right? So if we look at this uncum sum, we see that now it's containing the case every day. So you see here 111, that's 100, and then from the 23rd to the 24th, it becomes 2 cases. That means that that day there was 1 extra case, right? Then the day after, there were 3 cases. That means that day it was 1 extra case, right? So what we did here with this nifty stuff is basically uncumulative summing, the uncum summing, the decumulation of the sum, and then added that to the data frame again. So then I'll override the cases count with the uncum sum so that we now have the actual cases count. So if I look again at that, what we see now is that it's really the cases every day. And then what I'll also do is, so maybe let's just have a look at it now. And what do we see? Whoa, I don't get why there's minuses here. Okay, yeah. So if you have to run this multiple times, that's because I'm doing an override of cases here, and then I should actually, yeah, it would be better if I called this cases uncum sum or something. It's not actually good practice to override the column of the data frame with another column. But what do we see here, and that's something you might remember from all of these Corona stats, is that it's very seesaw-like thing, because there's little measurements happening in the weekends and lots of measurements happening during weekdays. So to kind of smoothen this out, what we'll do is we'll use a very nifty function that works out of the box very well, because we have set the index to the dates correctly by using just rolling averages with a window of 7. So we basically say every day slide up a window by step 1 and just calculate the mean over the 7 observations in here, right? So if we do that, and if we do COVID cases rolling plot, what do we see? Oh yeah, again, I have to rerun this from the top. It's something I should have done better in my code. So then in this case, it's way less seesaw, all over the place, right? So this is like the 7-day rolling averages that also, like in the news, they're talking about constantly. And then yeah, I can look at the result now with this. All right, so now I have like cases, like the means on a rolling basis, and I have these stocks. So the last step for me is basically combine the two, right? So the first thing I'll do is I'll create a new axis object in Mapleflip, and I'll plot all of the tickers, right? And the tickers, like the Y is the tickers, so that's I only show the these are basically all of the different series that I want to plot on my plot. And then because I set the index to be the date, the plot function of Matplot of pandas immediately understands that you want to plot this against the date on the x-axis. Then what I'll use is the TwinX function, which allows you to basically show the data for one, show you the data for one type of data. For example, here it's stocks data on the left hand, like on the left side, on the left axis, and to show the cases count, which is a totally different scale. It's not between 0 and 1. It's rather between like 0 and I don't know how much. Like yeah, I lost the image, but you'll see it in a second. You basically create two, like a shared x-axis, a shared date axis, but then a y-axis on the left hand side and a y-axis on the right hand side. So I'll do TwinX, and again, I'll store this in an axis object. Still nothing is showing, and we see already here, like there's already these two y-axes showing, right? Then we will use COVID.plot, and then we say cases rolling on the y-axis, see the color is black, and then x equals x1, so that we plot this on the same image, and then we'll show this, so that we don't see the nasty printout. And what do we see indeed? On the left-hand side, we see the normalized stock. On the right-hand side, we see the cases count, like the daily cases count. So at the worst moment, it was like 250,000 cases every day, and that was at the beginning of this year, which is pretty scary. So if we then start interpreting this, what do we see? That there's a huge drop, but actually that the huge drop in stock value already happened even before there were a lot of cases in the US. So it was really anticipation by investors that like gave them a scare. And what we also see, interestingly, is that when the pandemic that is at its height, like there's crazy amounts of cases. Of course, like these first bumps, they're like underrepresented because there wasn't enough testing equipment, etc. So it's possible that these bumps were even way higher. But what you see is that even though like pandemic is in full effect in some places, like in the US, that a lot of stocks like this, for example, the orange one is the Netflix stock, like this rebounded like crazy already. What you saw is that even like the booking stock for like a travel company, the stock is higher than it was at the start of the pandemic. Is higher than it was before the pandemic, even when Corona is like in full effect. And what you also see is that, for example, Microsoft, like they started low, they had a slight dip, but then it's all the way up from there. So they really proved themselves to be like a pandemic-proof company with all of the internet services that they provide. So you could say, like, I can add a small analysis here. This is not codes, it's not super important. So you can say, indeed, interestingly, the sharp decline in value already happened way before the number of cases in the United States started to skyrocket by the time the pandemic was sweeping across the country. Some stocks like Microsoft already rebounded to levels seen before COVID. So you can do a small analysis here. We can clean this maybe up a little bit, or is this fine like this? I actually think this looks pretty good. I can maybe, let's plot all closing prices, maybe normalized closing prices over time. Overall, like, let me maybe just run this top to bottom again. So I can do run all cells, run selected cell and all below. So that's basically running it again from top to bottom, which is also something that my publication will do for me, but I just want to be sure that this all works out of the box and the publication won't cause any problems. So we see indeed, like, this all looks good. So again, I can click on share. I can select which notebook I want to publish. In this case, I suggest you select notebook.ipynb because that contains the work you did and not the work that I prepared for you before. And then I can click on publish. Again, wait for a second because it's running from top to bottom. And then in a couple of seconds, this workspace should be published. And then again, it will be automatically enabled, like the public access will be automatically enabled for the publication, and it will be automatically featured on my profile page. So I can check this out. What do I see? I see a good looking publication about stocks and COVID. I can also see on my profile page that now there's yet another data science project of mine, namely stocks and COVID, with a nice picture, is also featured on my profile page now. As such, I'm basically building up a data science portfolio, right? Like, this is something I could send to my employer, like to a potential future employer, and say, like, hey, I'm actually pretty solid in data science. Check out all of these projects of mine. This is something you can perfectly do with DataCamp Workspace. All right. So this was the second example I wanted to walk you through on analyzing stocks and COVID. I'm going to take a quick break to have a drink of water, and then I'll answer some questions before we move on to the third part of this code long. All right, so there's a first question by Cheng. She asks, could you, or he asks, I'm not sure. They ask, could you repeat why percentage and the exclamation mark were used? So what the percentage does, I'll start by explaining that. That's basically doing bash commands. So basically doing terminal commands inside your Jupyter notebook. To show this with an example, so I can, for example, I can run in the terminal. I can run, for example, ls -la for listing all files, and that lists all files in my current working directory, right? The thing is, you can also do this from inside Jupyter Lab. I can do exclamation mark ls -la, and I just get this exact same output. And the thing is, normally, if you're on a normal computer and you want to install some Python packages, typically you go to your terminal and you say, I want to pip install yfinance, right? And it would say, in this case, it would say, like, yeah, it's all there, like it's all, it was already installed, no worries. So the thing is, rather than having to go through your terminal, you can just do this from inside your Jupyter notebook, so that everything, like basically your entire data analysis is self-contained, and you don't have to include instructions like, hey, go to your terminal, do this and this and this and this to install all of these packages, right? The other thing is the other thing that Cheng asked were these percentage signs. So let me just remove this and then see what happens. So I do Shift Enter, and now there's all of these outputs that I also saw in the terminal. They're all being included in here, but actually it's highly uninteresting. It's something I don't want to include in my report, right? So what I do is I use, they call it a magic command, a magic keyword. The percentage capture is basically saying, I'm just going to swallow up any output that the commands in the cell generate. And in this case, it's all happening behind the scenes without any output. It's of course happening, but you don't see the output, and that way I can keep my report clean. I'm actually also doing this here because if you don't do it, you'll see that there's like a loader in here and it doesn't serve any value to me. So I just say capture, but don't show this output, but still, of course, the data object is there. All right, so I hope that answers Cheng's question. Then there's a question by somebody else. I'm not sure what the name is. It seemed to be initials only, PK. For such timeline plots, does the date need to be indexed always? So I'm not sure. Like Pandas is very good with dealing with time series data. I do know that if you set the index of a Pandas data frame to be the date against which like you're working with other data, it just makes things super simple for you. And Pandas basically just knows what you mean if you set the index properly. I'm sure there's also ways to do it without having the date be the index, but then everything will be definitely harder for you to do. Then PK also asks, can uncom sum series have negative values? So normally the uncom sum should not have any negative values because that's against the concept of like the cumulative sum. Like by definition, it's a sum. Like in this case, it's COVID case count. So you can't have negative cases. You can't unmark somebody. So this uncom sum array will contain only positive values if all is well. And we can also check that, but let's maybe have a look. I'll go like this uncom sum, that's like this numpy array here. And I can do np any of the uncom sum. Is any of the uncom sum smaller than 0? Yes, it is. Let me see. There's one in here that's indeed true. That is funky. This must be a mistake. This is interesting. I'm not sure what happened here. Maybe it was a correction of sorts where the authorities counted some cases wrongly or something. This is interesting. This shouldn't happen. So this is a classical case of data quality problems. So it's a great question by PK. I don't know what's going on here. By definition, it should only go up, right? So the uncom sum should always be positive. But yeah, I don't know what happened here. This is something I didn't realize happened. Then there is a question by Heath to talk for a second about NumPy operations that need to access the data in the previous record, like np insert and np delete. So yeah, I can maybe show an example, but I won't spend too much time on this because it's a bit technical. And I'm not sure if it really serves the code along here. But let me just show it an example. So I will create a NumPy array that is 1, 1, 3, 5, 5, 8, 9, like this, or 8, 12, like this. And this is basically the cumulative. Let's say that this is the cumulative sum, right? The next thing we do, we create a cumulative sum shifted. like this. I'll print CumSum like this, and then CumSum shifted. And what do we see? We basically made the, we removed the last value, and we inserted a 0. So basically shifted the entire thing up by 1 to the right-hand side, right? So all of this moved over, a 0 was added on the left-hand side, and the 12 was dropped on the other side. So what if I now do, where am I? I think I lost not here. If I now do CumSum, a pairwise calculation of CumSum minus CumSum shifted, what am I doing? I'm doing 1 minus 0, 1 minus 1, 3 minus 1, and as such, basically my my daily case counts are appearing again, right? And then I see indeed 1, 1 means day 1 there was a 1, but here there was only a 0, like no cases added. Then it went to 3, that means that here 2 cases were added. Then it goes to 5, means another 2 cases were added. Then it stays at 5 again, no cases were added. Then it goes to 8, 3 cases were added. Then it goes to 12, 4 cases were added. So it's just by moving it up and then subtracting it, you're basically getting rid of the sums in here, right? So I hope that answers the question for Heath. All right. So quick recap, what we did so far. We created a workspace from a workspace template here, a dataset template. We also created a workspace from a GitHub repository through this functionality. And in both cases, from that workspace, we created a publication and featured it on our DataCamp profile page, which is something I hope all of you also did. The last thing I want to show is a feature that we added recently, which is called integrations. And integrations allow you to securely store secrets in your DataCamp workspace so that you can access databases like, for example, a PostgreSQL database that is living somewhere else on the internet, not in your DataCamp workspace. So to show that off, I prepared yet another GitHub repository that, again, we will start from over here, and it's called DVD Rentals. All right, so here we have a public repository that all of you should be able to access again. So FILIP-SEH is my GitHub handle, and then the repository name is DVD-Rentals. So again, there's a IPyNB in there, a solution of IPyNB as well that you can check at to understand what's going on if you maybe missed a couple of steps. There's a README in there, you can ignore everything. So as usual, let's get started by going to my workspace dashboard, clicking GitHub repository, and then using Filip-SEH, DVD Rentals. All right, so it's saying that this is a valid GitHub repo, and again, I'm going to open this up in Python. Oof. I think we're hitting the limits of what is possible with GitHub, unfortunately. So this is a feature we added recently, and we hit the GitHub rate limits. Give me a second to check. I'm going to try it once more. Yeah, so the thing is GitHub doesn't, like, because everybody's like eagerly following along, we're basically hitting the limits of GitHub because it's constantly like our DataCamp service is asking GitHub, like, what are the contents of this GitHub repository? And because of that, yeah, GitHub is saying like there's too many requests coming from DataCamp and they're basically disallowing it. So what we'll do instead, this is not too bad, but we'll basically have to do it somewhat less nicely. What we can do here is download the zip. It's just like that. Then I can create a new Python workspace like this, just at the top over there, like so. I can just drag the zip file in here. I hope I can then expand this. I'm not sure if I can easily unzip this. Let me open up the terminal. unzip DVD rentals.zip, DVD rentals master.zip. All right, perfect. So this is what you can do, right? I'm also going to share this in the Q&A doc so that Senna can share this with the others. So basically the steps are basically download the zip from GitHub, open up a new Python workspace, and then upload the zip file into the GitHub, into the workspace, and then unzip DVD rentals using the terminal commands. Great. So now it's inside this folder here, which is fine, but I'm just going to move this to here. So I'm just going to get rid of this notebook here, because that's like the default notebook. And then I'm just going to move this all here. So now I have basically the same result, but as you saw, this was taking way longer. Good. So now I can open up Notebook IPyNB. Right. I'm going to wait for a second so that Senna can share these instructions and you can get things set up. So again, repeating, you can go to the GitHub repository, click on code, click on download zip, and then you can head over to your DataCamp workspace. Like to workspaces here, you can click on new Python workspace. That will open up a new Python workspace, and then you can. So then you land in here. I'll also call this DVD rentals so that I can use it for later on. DVD rentals, and then you can upload the zip file, and then you can use the unzip command inside the terminal, DVD rentals.zip. Right? I'll wait a couple of seconds longer so that people can follow along here. Good. I hope everybody managed to catch up. So the result should be that you can open up a notebook. Yeah, you can try to clean it up. It's not that important. The most important thing is that you have a notebook.ipynb with all of this, like basically with all of these, all the sample code that I prepared from the GitHub, like in the GitHub repository. So what it's saying, it's about analyzing movie rentals, right? So in this short notebook, we'll connect to a PostgreSQL database with some sample data around the DVD rental business, after which we'll visualize the data in Python. So in this notebook, we will access data in a PostgreSQL database that is on the Google Cloud platform, which is a bit like the AWS of Google. And we will do this all from inside our workspace. I also included a structure of the database here. So we see here that there's rental, inventory, film category. So there's all kinds of databases inside this, all kinds of tables inside this database. As a first step, let's create a SQL Alchemy engine. The database string is constructed with environment variables that were workspace integration. I'll talk more about that later. So typically how you do this, you say from SQL Alchemy, which is a common Python package to like connect to PostgreSQL databases. I'm going to import create engine. I'm going to use pandas. I'm also going to use import OS. I'm going to create a database string. And there I'm going to say it's PostgreSQL database, a certain user, a certain password, a certain host, a certain database name. And I would have to write all of these things in clear text here. I would say my user is such and such, my password is such and such, my host is this IP, yada, yada. This is not the correct IP, by the way. But this is actually very insecure, because if you then share this report with a friend or with a colleague, you're basically exposing your username and your password to these, like to your friend or to your colleague you're sharing it with. So this is definitely bad practice. What we did to fix that is basically the concept of a DataCamp integration. And that's something you can access from the left-hand side here. I'm quickly going to check the QA doc to see if there's any questions left. No, okay. I hope a lot of people managed to follow along. So instead of hard coding all of these things inside my database string, I will use the concept of an integration. And I can basically create a new set of environment variables. these environment variables, once I've created them, I can basically load them into my session and then use these environment variables to create my database string, right? So Senna will share the names and values that you have to use to follow along here. So the database host in this case is an IP like this. Then there's the database name. So that's the name of the database we want to connect to. That's DVD rental. Then there's database username. That is learner in this case. And then there's database password, and that's DataCamp. So that's basically, those are the credentials, like the details for you to access this PostgreSQL database connection. I'm going to give this a name. I'll call it DVD rentals 2 because I already experimented with it before. So I'm now going to create this. Great. It's immediately giving me some code that I can use. So I'll copy this to the clipboard. Then I'm going to go next, and it's asking, do you want to connect this integration to your workspace? This will, like, we need to restart your workspace session for this. Yes, I want to do this. So I'll say connect. Right now, my workspace is restarting, and it's basically making sure that these environment variables are now available inside my Python session. So I can check this by opening up the terminal and clicking env and seeing whether there's any database commands in there. And what I see indeed, there's database commands, database credentials in there. And indeed, my environment contains DB password, DB username, DB host, DB name. So basically the things that I just specified inside the integrations tab. So rather than hard coding all things in here, I'm just going to use the code that I copied from the clipboard. And instead of using DB host here, I'm just going to say DB host in here. I'll do like this because I can use format strings because I started my string with an F. Then the name of the database is I replace with this. The username is this, and then the password is this. And again, I have to wrap it inside curly brackets. If you can't nail down the syntax, don't worry. So you can just open up the solution.ipynb and try it out. And then copy it from there if you're not entirely comfortable with all of this. So let's have a look first at this database string. Oh, something's wrong clearly. I still have to wrap this inside curly brackets so that my string formatting works out. So this is basically the connection string that SQL Alchemy expects to create a database engine. So this is perfect. I'm going to uncomment this. Great. And let me just quickly try out whether I can just execute a random SQL query. So it's a very simple one. We'll just count the number of films, let's say, right? We'll count the number of films that are in the database of this DVD rental business. And what do we see? We see indeed that it can count it. So there's exactly 1,000 movies inside the DVD rentals database, which is a dummy database. That's maybe why the number is so, like it's a round number. So this works perfectly fine. So what I did right now, just for your understanding, I was inside DataCamp Workspace, and from inside DataCamp Workspace, I basically connected to a PostgreSQL database that is living inside a Google Cloud Platform data center, and I'm just accessing that from inside DataCamp Workspace without having to leave my DataCamp notebook, like my IPython notebook experience. All right, so this is fairly interesting, I'll say, just counting the number of films. But let's say we just want to see how often each film category was rented out. So this would require us to get like the rentals table, because then we know when there were rentals happening. And then we would have to link it up to category, like through the inventory, to the film, through the film category, and to the category. We would have to basically do a bunch of joins so that we can combine every rental with a certain film category. All right, so let's do that. So do like this. I'm just going to do a select star here for now. So I'm using triple string so that I can basically chop up my Python string into multiple lines, which is way more readable if you're writing a lot of Python code. So I'll do select star from rentals in the first place, a rental, then I'll inner join that with inventory. So this is SQL code I'm writing, right? So I'm writing SQL code inside a Python string. This is the inventory ID. So now we're linked up to inventory. We'll also inner join this with film using film ID. Those are that's the foreign key here. Inner join film using film ID. I don't use the commas here. Then I inner join from film to film category using film ID. No, so I'm wrong here. This should be through inventory ID. Apologies. And inventory should be through rental ID. Or wait, inventory ID, yes, and to film ID. And then I use, again, film ID. It's like this, inner join film category using film ID. And then I inner join category using category ID. All right. And then what am I interested? Basically inside the category table, I'm interested to the category name. So I do category name as category name. I'll also do, maybe later on, it can be useful, film title. So I'll put that in the front because it's like the first thing you'd want, I guess. So title, so it's film.title as film title, category.name as category name, and then also let's get the rental dates so we have some information. Right, great. So I did a bunch of joins, and now I see that, for example, the film title Freaky Pocus was rented out in 2005, since it's a pretty old data set, and the category name was music. All right. So the last thing I can do now, and that's the nice thing, because I have this data as a pandas data frame in Python now, I can very easily print this. Like I can do something now with this. I can basically, for example, calculate an aggregate or make a plot. All right, so let's do that. So I do a df, I group by the category name. And I'll count the size. What we see, there's 1,112 action rentals, 1,166 animation rentals, 945 children rentals. For different categories, there were different rentals. Again, to clean this up, I'm going to reset the index here. And going to use, basically because this size, this created a series, but I want to turn the series into a data frame again. So if I turn it into a data frame again, we see that the category name is now no longer, and is not in the mix now. And then let's already try to create a plot of this. Rather than using Mapleflip, I suggest we use Plotly for once. That's also a package that is by default available inside DataCamp Workspace. You don't have to install it yourself anymore. We'll create a bar plot of, let's call this aggregates, this data frame. This, create a bar plots of aggregates. X is the category name, Y is the count. All right. What does this look like? Wait for a second. Exciting. All right, great. All right, so you see a bar plot here, but I don't really like the way this bar plot looks because it's hard to compare. Like, for example, sports and animation, who is the winner here? Like, they're way too far apart, right? What I can do here to add to my aggregates, I can sort the values here by, for example, count in this case. And in this case, this is way nicer. So I do see that animation just does not win out from sports, that music is the least popular category that's been rented out. Foreign is like somewhere in the middle, animation and sports here. So this was just to showcase a bit how you can go from a workspace inside Python. This I should print to mark down. From a workspace completely written in Python, but access PostgreSQL data from inside this workspace. Again, if I'm publishing this, I'm not exposing any secret information because that secret information has been basically injected in a way into my Python session, but it's not being hard-coded into my Python code here. So this is way, way better than hard-coding usernames and passwords right into your Python notebook. So again, as usual, final step is basically to share this. I want to publish this with the world because I'm super proud of the work I did. have to wait for a second for it to run from top to bottom. But that's the important thing. So it takes a while to run, but that is because it runs from top to bottom. So it really verifies that every code cell, one after the other, works. That also makes sure that all the code you wrote works in the order that it appears inside the notebook. If I then open this up, I again see a good looking publication about analyzing movie rentals. With the Python code, again, no secret information is being leaked here. I am connecting here, I'm checking the data frame, I'm doing an aggregate, I'm doing a plot, and I have a good looking plot to end with. Again, if I check my profile page, what do I see? I see the DVD rentals data. Yeah, it's showing the first picture of the publication by default. I don't really like that, so maybe let me just get rid of the structure. This is also not very interesting for the reader, so let me just get rid of that. This, I hope. This should go, huh? Got this cell. And then this I can move in here. And then this I can do like this. And then I'll share, update again. Let's see what this gives. It's still running. Yes, now it's finished. Good. And then if I check my profile, the DVD rentals data, yeah, that's because Plotly is it's HTML library, so it's the thumbnail cannot be easily shown here. That's actually something we should improve on, so that also Plotly thumbnails can show up on your DataCamp profile, because this looks a bit boring, to be honest. All right, so that was it. We have 5 minutes left for some final Q&A, if there's people still with questions. And there are some questions. Yeah, so I made a mistake. So PK says she's getting he or she is getting an error on trying to unzip. That's because I made a mistake. It's DVD rentals master.zip and not DVD rentals.zip. Then Cheng asked, how do I know the specific value of the IP address of this database? Do I need to know it in my specific coding? So yes, indeed, this is something that you have to know yourself. So say, for example, you work at a company that has PostgreSQL databases that you can analyze, then you should go to the system admin and ask him or ask them, what is the IP address? What is the URL? Basically, where is this database hosted so that I can access it? So for this example, DVD rentals was contained inside, like DVD rentals was at the IP that is shown here. But for other databases, they will be in different places, right? So this is the IP address that I read off from my Google Cloud Platform console. So Google Cloud told me, this is where your database is running. This is how you can connect to it. So this is the IP address you should use. Then Abdi is asking the question, the integration feature is an excellent function. Is it secure enough to store credentials from another server? And is there any encryption involved? So that's a great question, Abdi. So yes, it's very secure. So we use an external service called HashiCorp Vault, which is known to be like the best in terms of security and encryption of secrets. So rather than us storing these secrets that you put in here ourselves, we basically depend on a very professional company whose main business is storing secrets as safely and as securely as possible. So every secret you store here is being encrypted in transit on the disk and only decrypted when you need it. So it's entirely secure. And then there's the question from PK, how much data can the notebook handle? So I'm not sure exactly what you mean. So there's different ways to answer this question. I would say that a workspace, you can put 3 gigabytes of data inside a workspace. You can go up to 5 gigabytes, but if you go over 5 gigabytes of data that you store inside one DataCamp workspace, then you lose access to your workspace. Of course, we can still get you the workspace data afterwards, but we, for now, set some sort of a fair limit use on 3 gigabytes of data. Then in terms of how much data can the notebook handle, it can also be in terms of processing power, in terms of working memory, so in terms of the RAM workspace gets. So you get 4 gigabytes of RAM inside DataCamp workspace. Depending on how complicated the algorithms are that you do, this becomes a problem sooner or later. But for like the basic analyses we did, for example, accessing PostgreSQL data, this is not like this shouldn't be a problem. The RAM shouldn't be the problem. If you're going to do crazy ensemble methods, or you're going to do hyper parameter tuning for different random forests, that's moments when you could potentially hit the limit. If you do hit the limit, definitely let us know through the feedback modal over here. Let us know, like, hey, I'm hitting the limit for my analyses, and that's good information for us to at some point also increase the resources we give every person on DataCamp Workspace. So I also hope that that answers PK's question. Are there any other questions? All right, cool. Senna lets me know that there's no additional questions. So I think we can leave it at this, right on time. Only 90 seconds left before it's 6:30 here in Belgium. I want to thank you all for attending. Slight hiccup at the end with the DVD rentals data. Probably in an hour, you'll be able to start the workspace from the GitHub repository again. But thanks for staying with us. Thanks for tuning in. And I hope to see you soon in another code along session where I'll hopefully be able to showcase more nice DataCamp Workspace features that will help you basically do data science in the blink of an eye without having to configure or install anything on your own system. Thanks. Goodbye.
Thank you, Philip. Just some closing messages here. We'll be organizing more of these presentations in the future, so stay tuned, and please let us know if you have any additional feedback regarding these sessions. We will post the survey link in the chat, but also on Slack along with the recording. So your feedback will really make a difference in helping improve the future events that we hold and improve Workspace as a whole. And finally, if you haven't already, please feel free to join the DataCamp Global Slack community, where we will keep you updated about new Workspace features and events that are happening. So this rounds up the 4th Workspace Live Code Along session. I remind you that the session was recorded, and the link to the recording will be posted later on Slack, email, and social media. So with that being said, have a great rest of your day, and thank you for joining.